We now have the channel model probability and the prior probability. So we can multiply these two and take argmax and rank the candidates now. So this is the channel model probability, this is the prior probability, and we can multiply these two and then we'll take argmax, and that shows across is the most probable candidate for the mistake across. Okay, so let's see what the sentence was. A stellar and versatile actress whose combination of sass and glamour. So our noisy channel model multiplied with unigram prior probability says that across is the most probable candidate. But can we use across here? A stellar and versatile across whose combination of sass and glamour. Obviously this is not correct. So what can we do to deal with this now? We can use context now. So instead of using a unigram language model, we can use a bigram language model. So this is the error word. There are two bigrams here. Let's say across is the candidate, generated candidate. So we have a bigram across given versatile, and the second bigram would be whose given versatile. So we can use those two. So these are those two probabilities. Whose given versatile given across, across given versatile and whose given across. We can multiply these two probabilities to get the probability of versatile across whose. And then we have this candidate actress. So the bigrams would be actress given versatile, and we have probability for that as well. So now when we use bigram language model, actress is the more probable word, and this is actually true. Alright, so there are some spelling error test sets that are available online. You can go check them. That was all about non-word spelling errors. We saw how we could detect them, and then we saw how we could generate candidates, how we could rank those candidates using the noisy channel model and the language model. We saw how we can use context to improve predictions. Now we'll move on to the real word spelling errors. So this is a sample which has some real word spelling errors. So leaving in about 15 minuets. So this should be minutes, but it is minuets instead. So the design and construction of the system, this is probably and, the design and construction. And is also a real word. So this is a real word spelling error. Can they leave him? So this should be leave. The study was conducted mainly this should be by John Black. So a study shows that out of all the spelling errors, approximately 25 to 40% are actually real word spelling errors. This would actually depend upon the type of application. So depending upon the application, spelling errors could either be a quarter of the total or up to 50% or half of the total. In case of non-words, we just needed to do a lookup in the dictionary to detect the spelling errors. But we cannot do this for the real word errors because that real word would also be present in the dictionary. So how we can generate a candidate set? So for that, let's first talk about what are possible candidates. Possible candidates are the words with similar pronunciations and similar spellings. But how to first detect the error? There is no way to detect a real word error. So we'll actually generate candidates for every word in the sentence or every word in the query or the text. So for each word W in the in our query, we'll generate a candidate set, And how we can generate this candidate set? This candidate set can be generated as we generated the candidates for non-word spelling errors using edit distance. In the case of non-word spelling errors, we discarded that non-word. But now that each W is a real word, we also need to consider this W as a possible candidate, because most of the times user write correct words as well. But since we have no way of actually identifying an error, so we are considering and assuming that every word could be an error or every word could be correct. So we need to include that original word in the candidate set as well. So once we have generated candidates for each word, the next task is to rank those candidates, choose best candidates. For that, we can again use noisy channel. Okay, so for every word in sentence, which could be a phrase or a query, generate a candidate set which includes the word itself and the single letter edits, and the words have same words which have same pronunciation. We can ignore this one for the time being. We'll only consider this single letter edits, and then we can rank them using noisy channel. Okay, so given a sentence x1, x2, x3, these are the words. x1, x2, x3 are up to xn are the words of the sentence. We will generate candidates for every word. So candidates of x1, x1 itself, and the possible words which are one edit distance away from x1. Then we generate candidates for x2, and similarly we can generate candidates for all these words in the given sentence. Now how we can find the exact or the correct sequence? We will choose a sequence W that maximizes P of W given x1 up to xn. Now this sequence W actually comes from all these words. So one possible sequence is actually x1, x2 up to xn. Second possible sequence could be x1, w2, x3, x4 up to xn. So there are many possible sequences now, and we'll have to find probability for all these sequences, and whichever has the maximum probability, that would be our correct sequence. So again, we will be using Bayes' law, and this is the noisy channel model. This is the prior probability. Consider this example 2 of 2. So the possible candidates for 2 could be these, and now look that 2 is also a part of possible candidates, and possible candidates of are these, and possible candidates of Thu are these. So Thaw is repeated here, one of these should be Thu. Now there are many possible sequences here. For example, 2 of, through, 2 of, through, 2 of, the. So we'll see how we can find which of these sequences is the most probable. As we have lots and lots of possible sequences of the words, so we'll make a simplifying assumption. We'll assume that at a time only one word is misspelled. So given a sentence, we'll assume that only one of the words of the sentences of that sentence could be wrongly typed. For example, only 2 of few apples, oily, 2 of few apples. So we are considering only one mistake at a time. Only 2 of few apples. This is how now we have reduced our number of sequences. We can calculate prior probability and the noisy channel probability as we did for non-word errors. The only change that occurs now is that we also need the probability of correction. So if you remember in a confusion matrix for non-word errors, the diagonal entries were zeros. Then now we need those entries too to find this probability of the correct. So let's come back to our previous example. So considering that this word was the error word, and these are the candidate words for this error. These are the edit operations that resulted into this error. And we have these noisy channel probabilities and the prior probabilities, and we can multiply these, and then we can take argmax, which tells us that this candidate word "the" is the most probable word for this error. That's all about real word errors. This concludes our topic of spell correction.